Salutations, fellow chemists, welcome, and today we're looking at particle theory. We're focusing closely on the three states of matter, and we've got solid, liquid, and gas. For this explainer, I'm just going to take you through the arrangement and their properties and how they move as well, and look at an easy, medium, and hard question in this video. So to get started in red, I'm going to show you and tell you about their arrangement. So first thing, the arrangement for a solid, you can see is ordered. Okay, so that means there are nice, neat rows and columns that has a neat order. And when we talk about a liquid, you can see the arrangement of these particles here. They are close together, but not as ordered as our solid. They're not in nice, neat rows and columns here. And when it comes to a gas, let's move over to this side. For a gas, you can see here, these are far apart. And in a different color now, I'm going to go for the blue. In blue, we're going to talk about their movement. So how do they move? So first one, for a solid, they are only allowed to vibrate in a fixed position. Yeah, poor solids, they're fixed to their position there. And for our liquid there, you can see the liquid here has the freedom to move over each other, but they still stay stuck together. And the gases has the most freedom in our gas state. They have the most freedom to move around. So the particles here move in random directions. And you can see as the freedom the particle has to move around increases, so from solid, liquid to gas, the more kinetic energy they have. So kinetic energy is just the energy to move, yes, movement energy or energy associated with movement. And what we're going to do now is apply these to some questions. Okay, so let's go. To get started, let's have a look at the easy question. So this one says, which state of matter has the weakest forces of attraction? So remember, attraction means to bring things together. So here, if you think about the different states here, so I'm drawing these super quickly. You can see I'm on speed mode here. And let's do it for a gas. What you can see here, solid, liquid, and gas, very quickly. Gas over here. What you can see here, the ones that are most attracted to each other will have the strongest forces of attraction. So for a solid, they're all very close to each other, so that means they're really attracted to each other there. So they cannot be a solid. Liquid, also, they're stuck next to each other, so it cannot be a liquid. The right answer is gas. So our answer here will be gas. It doesn't say explain, but I'll give you the explanation. The explanation is because in a gas, the particles are far apart, and the further apart they are, the weaker the forces of attraction between them. And that is it for the easy one. We'll move on to the medium one next. Sweet, so medium question now. Let's have a look. It says, explain why gases can be compressed, but solids cannot. So in my blue, I'm going to circle this keyword here. We need to give reasons when we explain. And here it says, why can gases be compressed? Remember, to compress means to squish. So we're bringing things closer together. So I'm going to draw the pen drop there. I'm going to draw the diagram for a solid. And this is our solid. It shows the arrangement of the particles here. And I'm going to do it for a gas, nice and small this time, so we have space to write around it. And I'm going to swap around to my blue pen. And if we look here and think about compressing and squishing a solid, you can see in our solid, these are close together. The particles are close together with no gaps. And that makes it very difficult if you're trying to squish something and bring it together and close together and you have no gaps, then that's basically impossible. So here it is difficult to bring particles closer as they are already close enough. Whereas when we look at the gas here, you can see the particles are far apart with lots of gaps. And that makes our job very easy because we have lots of gaps here and we're trying to bring them a lot closer together. It's very easy to do that. So it's easy to bring particles closer when we have so many gaps there. Okay, so that's it for the medium one. Now we move on to the hard question. So this is our last question, and this is the hardest out of the three we've seen so far. And it says, why does heating a substance usually cause it to expand? I've already drawn the particle diagrams here for us for the state solid, liquid, and gas. Question says why, so that's similar to explain. So we need to give reasons here. And heating, you need to be aware, why does heating a substance usually cause it to expand? Heating here adds more energy. And in this case, it's kinetic energy. Remember from earlier, kinetic energy is the energy associated with movement. And here, expands means it's going to take up more volume or more space. And the volume here is the space a substance takes up. Takes up here. Okay, so why does heating a substance then cause it to expand? So here, if you look at a solid here, remember the solids are vibrating in fixed position. If you give it more kinetic energy, if you give it more freedom to move, then it's going to be close to a liquid, it's going to become a liquid, and it's going to now move over each other. Okay, and if you give it more and more energy again, it then starts to move in random directions, just like we see in a gas. So it becomes a gas there. So as we're going along here, all I'm doing is increasing the kinetic energy. Kinetic energy is increasing here. And the way we can do that is to add heat, increase the temperature. So that's what happens there. The reason why it tends to expand is because here, from a solid to a liquid to a gas, the particles are taking up more and more space, and we can only do that as we give them more kinetic energy. And the way we supply more kinetic energy is by heating. So hopefully you're able to understand all of these here. I haven't written words over here, but my diagrams and this here showing you the increase of kinetic energy should help you to understand this last hard question. And that is it for the video. It leads on nicely here to our state changes. So watch out in the next video where I talk about the state changes and we look at heating curves as well. Take care, make sure you subscribe, and I'll see you in the next video.